Okay, I'm going to draw my concept of a ORBO motor that might even be able to loop. Okay, first of all, you get some soft steel wire, maybe thick, maybe 3 millimeters thick, and you're going to use that as a core. So you start out and you make a core. You make a core as a loop of wire, you know. So looking at it sideways, you know, you're kind of like a coil, but maybe only 5 millimeters deep. Depends on how strong your magnets are. Now, if your magnet is this big, let's say you have a disc magnet that big, make the loop of wire for the core of your ORBO motor the same diameter as your magnets, the outside diameter of your loop. Okay, so here's the idea. You take this wire and you make a loop, and there's your core for a toroid coil, a toroid type coil, because that's how ORBO motors work. I'm going to make this simple and just do 3 cores. And but you could do 8, you could do 16, you could do 50, whatever you want. Okay, so now you still have this continuous wire. Let's just dangle it out here. So you made a loop for a core. Now take the wire and go like this to the next loop for a core. Okay? Take the wire, go like this for the next loop, and this is all one continuous wire, remember, and then do it the same here, like that. So you'll have something like that. It's kind of ugly. And then why not have 3 parallel wires as your core wire, and make another one, another one, and another one. Why not? And why not do another one, and another one? And now this is all one continuous wire. You loop it around, pull it around, loop it around, pull it around, loop it around, pull it around. Okay, now these are going to be not influenced. Now the rotor will be a, I'll draw it with the red ink. The rotor will be a magnet, 3 magnets, same width, you know, as the looped core. And the rotor will be lining right up with these, right? So it'd be 3 magnets at 120 and 3 coils at 120. Okay, so I'll just draw the rotor. So that's the rotor spinning spinning past here. And then make 2 of these stator coils. If this is the rotor, make stator coils here, and do that loop thing. You know, I'm just drawing it rough here. So have them on both sides of the rotor magnets, okay? So these are magnets, you know, magnets in here. How thick you want to have the cores be of the looping wire depends on how strong the magnets are. If the, you know, kind of just take a paper clip and see how far, like you have a magnet like north, south. See how far the flux, stretches out, and you can feel it. And have that, the length, the width of your core. Okay, now, if any of you know how ORBO motors work, the rotor magnets attract to the cores, the soft steel cores. And then it wants to go past for momentum, but it's going to pull itself back. And so that's why you can't just have permanent magnets, of course, just rotate past steel, because it'll pull, but then it wants to pull again coming back the other way. So the timing of when you energize the coils is right at the point when it wants to pull back after being attracted. So you get a free attractive stroke, and then the toroid coils shield the magnetic field of the rotor magnets. So it goes right past. So these cores, they need to be toroidal wrapped, which means to wrap like this, Solenoid coils are what you normally see in pulse motors and stuff, like this. Toroid coils, just in case some of you guys don't know, they wrap around like this, So these need to be toroid coils. Now, here's the trick. What's going to be cool is wrap coils like this all around these. That's a long length of wire that's going to be induced every time you fire these, energize these toroids, because it shares the common core. And then same with these. You might as well do these too. And then, so there's more. And then these two, and do them on all three. Okay, so every time this pulses, to shield the rotor magnets, every time it fires a motor pulse, you could call it, it's going to induce a lot of power into here. And because they're going out like this, like flower petals or whatever, it's going to not have any Lenz's law, because it's not reacting to the rotor magnet spinning around. So, so that's my idea, how to make an ORBO looper. So each of these, you put a diode on them, fill a cap, and each of these winds will have a diode, fill a cap, and now have the cap be what's pulsing into the motor for a looper. Anyways, kind of a messy drawing, but I think you get the picture, what I'm thinking. And so there it is, ORBO concept of a looping motor. Okay, thanks a lot for watching. Okay, bye.